Bismillahirrahmanirrahim. In this session, we will discuss the Cambridge Assessment International Education Exam of Physics, code number 5054, version 11 from May-June 2024 exam for 1 hour. Here we will deal with some multiple choice questions. There are 40 questions in this paper. And here we have the first question. A measuring cylinder contains water is placed on a top pan balance. Here a measuring cylinder is placed on a top pan balance. An object is placed in the measuring cylinder. An object is placed, this object is placed here in this cylinder. So the result is mass increases and its volume also increases. And what is the mass and what is the volume of the object is being asked in this question. And we have options. Mass is 10 and volume is 7. Mass is 10, 34, 34, 10, 34 and 17. Here we can see that the volume is 7 and after that it is 17. So the volume is 17 minus 7 is 10. So volume is 10. So this volume is 10, and here we see that the mass is 20 grams and the mass after adding into the cylinder is 54 grams. The difference of mass is 34 grams. So this option C is correct. So we have seen that the mass increases from 20 to 54 and volume increases from 7 to 17 cc. So therefore the volume of the object is 17 cc minus 7 cc is equal to 10 cc, that is centimeter cube. So the correct option is C. And what is the quantity, which quantity is a vector? So here we have option distance, force, mass and speed, and we know that the force is a vector quantity. So any quantity having magnitude and direction is called vector. So the option B is correct. But these questions may be asked with different quantities. So we have enlisted all the vector quantities, and so that we can solve the other questions in the next appearing exams. So for future we have included all the quantities that is vectors. So the first one is displacement, velocity, acceleration, force, torque, weight, momentum, angular momentum, electric field, magnetic field, displacement, current, gradient, normal force, frictional force, lift, and lift is an opposite of weight in the upward direction. So these are all vector quantities. So we should learn these things. So this kind of question may be asked every year, almost every year. The table shows the distance traveled by a car in each 2 seconds time interval during a 12 seconds period of its journey. So the time interval from 0 to 2, the distance traveled is 10 meter, and from 2 to 4 the distance traveled is again 10 meter, and from 4 to 6 distance traveled is 11, and 6 to 8 distance traveled is 13 meter, 8 to 10 16 meters, and 10 to 12 23 meters. So the speed in 0 to 2 is 5 meters per second. From 2 to 4 again interval of 2 seconds is 5 meters per second, and again 4 to 6 11 meters. So in 2 minutes speed is 5.5 meters per second. For this, 13 divided by 2 is 6.5 meters per second. For this, 8 meters per second. For this much interval, 23 divided by 2 is 11.5 meters. Here we can see that here the acceleration is 0 because the speed is constant. From here to here the speed is increased in 0.25, but here to here the increase in speed or acceleration is 0.5 meters per second because from 6 to 8 it reaches from 6 to 8, and from 8 to 10. So this is the acceleration. This is 0.75 meters per second because the speed difference is 1.5 meters per second divided by 2 seconds. So this is 0.7 meters per second. And here from 10 to 12, 16 to 23 in a speed 2 seconds interval. So subtract this, v minus u divided by t, delta t is 1.75 meters per second. So we can see that the moving with a constant speed, yes, the option A is correct, but followed by a non-uniform acceleration, yes. So the correct option is A. Then uniform acceleration, no uniform acceleration, speed is constant, so the option A is correct. 0 to 4 seconds is resting, no, it's traveled the distance of 10 meters, so this is C and D is wrong, and option A is the correct option. Two cubes x and y, a cube x and a cube y has the same mass, but the length of side of x is twice that of y. So the length of x is one side length of x is 2 times the length of y. So if this information is given, and the density, we know that density is equal to mass upon volume, and volume of y is equal to one side length is L, so this is a cube, so 3 dimension length, so it becomes L cube. And so volume of x, so one side length is 2L, so 2L, so it becomes 8L cube. And we divide the mass of x divided by volume of x, so mass of x is m and volume of x is L cube. Oh sorry, y, this is y, this is y. This is x, sorry, right, this is x and this is y. So density of x is mass of x, volume of x, so mass of x is m and volume of x is 8L cube, so we have write down 8L cube here. And density of y is mass of y divided by volume of y is L cube, so this is density of y, and we have to find the ratio of density of x divided by density of y. So in the numerator we will place m upon 8L cube in the numerator, and in the denominator we will place there m upon L cube. So everything will be cancelled and the rest will be 1 upon 8. So 1 upon 8 is 0.125. So the correct answer is option A. So this is also very good question. Question number 5, an object slides down a frictionless slope as shown. An object presses on the surface. The surface pushes back on the object. The surface is also pushes back the object. In which direction does the surface pushes back on the object? In which direction? So this option B and C. So if the object is placed on a horizontal plane, so this would be the normal force. But since the object is placed on an inclined plane, so the object normal force is always in the direction of the object placed. So this option C is correct. So when an object is we can learn it from here that when an object is placed on a flat solid surface, it exerts a gravitational or weight force down on the surface. So if it is placed on a horizontal plane like this, then the normal force would be B. But however, when an object is placed on an inclined surface, the normal force is perpendicular to the surface. So this is the surface and its perpendicular surface is this. So this option C is correct. And this means that the normal force does not act directly opposite the force of gravity. These are illustrated on the normal force inclined plane diagram. So this correct option is option C. This is very important question. Now question number 6. A car traveling on a straight road brakes and comes to a rest. Which row gives the expression for calculating the thinking distance and gives a variable that affects thinking distance? So since thinking distance plus braking distance is equal to stopping distance, as a result the car speed decreases. So since thinking distance plus braking distance is equal to stopping distance, if we stop thinking distance, we think and then apply brakes, and as a result the stopping distance achieved. So here we have to find a thinking distance. The thinking distance is equal to stopping distance minus braking distance. Stopping distance minus braking distance is this one. So option C, this part is correct, but it will not affect the load carry but speed in steady speed. So the option D, the stopping distance minus braking distance, and the variable that will affect thinking distance is the speed of the car. So speed of the car is the option. So the correct option is option D here in this question number 6. This is very important. This is a practical problem. An unstretched spring of length 15 cm stretches by 4 cm when a mass of weight 6 Newton is suspended from it. So when a mass is suspended, the change in length is 4 cm, and so the Kf is equal to K into delta x. So change in stretch length is delta x, and this is spring constant. So we can find the K is equal to F divided by delta x. So F divided by delta x. So 6 Newton force is applied and it stretches 4 centimeters. So as a result, K is obtained as 1.5 newtons per centimeter. So the spring does not exceed the limit of proportionality. It means that the spring is working under a linear relationship. So what is the total length of the spring when a weight of suspended mass is 3 Newton? So instead of 6 Newton, if we place 3 Newton, half of this weight, so what will be the total length? So the delta x can be obtained is equal to F upon K. Delta x, we have to find the delta x here. So delta x is equal to F upon K. So F is 3 newtons and K is obtained as 1.5 newtons per centimeter. So this 3 will divide by this 1.5 newtons per centimeter. So as a result, the 2 centimeter is obtained. So x is equal to the total length will be the unstretched length plus delta x is the change in length. So unstretched length is 15 centimeter and the delta x as a result of this 3 Newton force is 2 centimeters. So 15 centimeters plus 2 centimeters is equal to 17 centimeters. So the total length will be 17 centimeters. That is the correct option. That is option D here, 17 centimeters. Which statement describes the moment of a force about a pivot are correct? The moment of force is measured of the turning effect of the force. Moment of force is equal to the force into perpendicular distance from the pivot. The moment of force is equal to the force into pressure on the pivot. So we know that moment of force is a measure of turning effect of the force. So moment of force is also turning effect of force is a torque. So part 1 is correct. The moment of force is equals to the force into perpendicular distance from the pivot. This is also correct. So 1 and 2 is correct. The moment of force is equal to the force into pressure on the pivot. No, this is wrong. So option here 1 and 2 statements are correct. So option A 1 and 2 is correct. The moment of force is also known as torque, is a measure of how a force will cause a body to rotate around a specific point or axis. So the moment force is a torque force and which rotates the body around a specific point or axis. So it is calculated by multiplying the force by the perpendicular distance. So the moment of force or torque is equal to force into perpendicular distance from the pivot. So this SI unit of this moment force is Newton meter. That's why. So this option A is correct here. Now we have 4 objects have identical shape but different distribution of mass. Here identical but different distribution of mass. The mass distribution is different. The center of gravity of each object is shown by the dot marked G. Here the center of gravity is this. Here center of gravity is here. In C case the center of gravity is at the bottom here. At D the center of gravity is here at this side. So the question is which object is the most stable? So the option C here, because the center of gravity is lying at the base, so this should be the most stable. So we should learn that the center of gravity, this option theory should be very important regarding this MCQ. The center of gravity of an object or a person affects stability. So center of gravity always affects stability or its ability to maintain balance when disturbed. So lower center of gravity, an object with a lower center of gravity is more stable. So this is lower center of gravity at the bottom side, so this is more stable. Secondly, higher COG, an object with a higher center of gravity is more likely to topple if it's pushed. This kind of here, because the most mass here, so it exerts there, so it will topple. So base of support, an object is most stable when the center of gravity is near the center of its base of support. So here it is existing at the base of support at the bottom side, so center of gravity at the base, so this will make it stable. So this is the option. The line of gravity, when the line of gravity falls outside the BOS, the object is unstable and needs a postural reaction to maintain balance. The COG is the point at which an object weight acts. An object will fall over when its COG passes past the base of the object as it tilted. So here, if a force is applied on this direction or a force is applied on this direction, it will tilt. Because this weight is exerting in this direction. So a small disturbance can topple it, but this is here it will be more stable. More force will be required to topple it. So in this case, this option C is more stable. An object of mass of 5 kg is pushed up a slope at a steady speed of 2 meters per second. So which calculation gives the change in gravitational potential energy from the bottom to the top? So gravitational potential is equal to mass into gravity into the change in height. So here the mass is 5 kg, so this is 5 kg, and the gravity is 9.8 meters per second or 9 meters per second square, and here the height change is 3 meters. So from this bottom to the top, this is 3 meters. So this option is correct, which is option B. This is all from part A. In the next session we will cover from question number 11 to 20.